Good morning. Got just enough time to talk to you about baby pandas and pizza deliveries and linear functions, and it's going to be great. So let's start with a couple of scenarios. Baby pandas. Okay, so we've got two baby pandas in a zoo, and I've used this example for several semesters. Got it from Buncombe County. There's a panda named Mochi and a panda named Kappa, and that's just so exciting because what could be cuter, right? And basically, we have information about each of the pandas. And what we're going to do is we're going to compare them and answer some questions. So here's what we know about panda. At birth, about Mochi the panda. At birth, Mochi weighed 1 pound. After 1 week, 5 pounds, then 9 pounds, then 13 pounds. Surely you see a pattern. Kappa, on the other hand, the information that we're given is that Kappa's weight is modeled by the linear equation 3x plus 2. So let's check it out. Question, which panda was heavier at birth? All right, so how can we tell this? The table lets us know that Mochi weighed 1 pound at birth, while Kappa, what do we look at? Well, you would look at the y-intercept. The y-intercept is 2, meaning that that's the value at x equals 0. You could also evaluate at 0. 3 times 0, 0 plus 2 equals 2. So Kappa weighed 2 pounds at birth. Mochi weighed 1 pound at birth. Kappa was heavier. Next question. Which panda is growing faster? For growth, we're looking at average rate of change. Average rate of change, we can look at it in many ways, whether it is through the graph, the equation, the table, or the contextual representation. All 4 of these, we can tell the difference between a y-intercept and a rate. So the question is, which one's growing faster? If I look at Mochi, it looks like it's increasing 4 pounds per week. That's the average rate of change, 4 pounds per week. The cool part about linear functions is the average rate of change does not change ever. So if the average rate of change is 4, it is going to remain 4 for the entire domain of the function. So Mochi, 4 pounds per week. Look at Kappa, 3 pounds per week. The 3x is the term that contains the slope. So Kappa is growing 3 pounds per week. Mochi is growing 4 pounds per week. Mochi is growing faster, even if Mochi was lighter at birth. One more question. Which panda will weigh more at 5 weeks? 5 weeks. So let's take a look at that one. At 5 weeks, it looks like, well, we're given information that Mochi is going to weigh 13 pounds at 3 weeks. We could assume that if we add 4, we get 4 weeks. All right. So let's add 4 more. So we get 17. And we could add 4 more and get 21. All right. So it looks like it's going to weigh 21 pounds. Let's look at Kappa. If we're going to find Kappa's weight at 5 weeks, what we're going to do is we're going to evaluate. Think about it. Evaluation means take an input, find the output. We know the input. The input is 5 weeks. We don't know the output. So we say y equals 3 times 5 plus 2. All right. In other words, y is equal to 17. 17. 3 times 5 is 15 plus 2, 17. Who weighs more? Well, who else? Mochi the panda. Mochi weighs 21 pounds at this point, while at 5 weeks, Kappa is going to weigh 17 pounds. So that's the way the cookie crumbles. That is comparing linear functions in a nutshell. Nothing too bad about that. You're going to see another example in class today talking about pizza deliveries, which I find pretty neat. It's pretty cool. We need to basically understand the 2 main aspects of linear functions, which are linear functions have 1, a starting value known as the y-intercept or the 0th value, and 2, a linear function always contains a rate of change, an average rate of change, and we call that average rate of change the slope. That rate, slope, average rate of change is constant, a constant average rate of change. And we can find that, we represent that average rate of change through the following equation. Y equals mx plus b. And I'm not going to have enough time to type it, to draw it with this lag, but hopefully you know what I mean. Y equals mx plus b. M is the slope, b is the y-intercept. M is the rate, b is the starting value. Let's go.